Hello class, welcome to week 8. Today the topic is data management layer design. So we are still in the design phase of workflow activity of the unified process. So basically in this phase we are concerned with accessing data and working with the data. Now what we have so far, we have activity diagrams, we have use case diagrams, use case descriptions, and if you remember in the last 2 weeks we have had class diagrams. Class diagrams are basically depicting or basically it's like having real world objects in software. For example, we have a student class that has, of course, attributes like first name, last name, date of birth, and has operations like register. This class is used as a template for creating objects. For example, I can create an object called John, and this object has actually is the name of the object to store data about John. For example, first name is John, last name is Brown, date of birth is 1/1/2000, for example. And of course, object John can register, will be able to actually register for a course, for example. So now we have the data in object in memory. How do we persist this data? Which means, okay, how do we save it or store it somewhere permanently so that when you are not using the software, the data about John is recorded somewhere, is saved somewhere. So that's the topic of today. How do we design our data management layer? Basically, how do we design our object persistence? Of course, we have different types of object persistence. We may store the object data as a simple file, as a what we call flat file. So we just save the data about John Brown in a small file somewhere. First name John, last name Brown, and date of birth 1/1/2000. Next time we want to use object John, we go to that file, we open the file, we read the file, and we initialize our class object John with the values that we find in that file. That is one way. Of course, it's just a simple file. Other way, which is more efficient, is of course to use a database. So we store our object class data or object data in a database. Now we have, of course, different types of databases. As you know, we have relational database management systems we can use. We can use object relational database management systems, which is a type of relational database management system. We can use object-oriented databases. We can also use even big data databases. So it depends on the requirements, speed, performance, the volume of data that, of course, we should consider. So what do we do today? We learn, first of all, different types of object persistence formats like file databases. Then we learn how to actually map the problem domain objects to different object persistence format. What this means really is we have several classes for a problem domain or for an application. And these classes, the objects of those classes which have data need to be stored somewhere. So how do we actually map the data in an object to some tables, for example, in a database? How do we map the attributes of an object or attribute values of an object into a database or a file? How do we map the operations or methods of an object into a database or a object persistence environment? So also for this matter, we design what we call data access and manipulation classes, or in short, DAM classes. Now, these classes, what they do, they manage the interactions with a data persistence environment, or in other words, with a database. For example, you use these classes to insert data, add some data about the object into the database, or use these classes to read some data from database, and basically these classes are used for that purpose. Also, you will see a sample code in C#. Now, as I have already said, sorry. As I have already mentioned before, we have different environments for creating software. For example, C#, which is a Microsoft product, usually is developed using Visual Studio, which is a free product, of course, the community version of it, and you can use to develop applications. Now, I have given you the instructions in week 1 of the slides about how to install Visual Studio. So if you're interested, and I really advise that, of course, download the Visual Studio 2017, which is the latest version, and install it on your computer. Of course, I will give you the code for the sample implementation that we are going to have, so you can actually exercise and test the code, work with the code. So you go to a website and you want to search for something, and then it takes time. For example, you are searching for some products, and you see that your computer is showing that clock, the hourglass clock running, and it takes 10 seconds, 20 seconds, 30 seconds, still you don't have answers. So usually the issue of performance goes back to the how you have actually persisted your data, or in other words, goes back to the database, how you have stored your data and how your database is performing. So in the design phase of, or the workflow of the unified process, we are designing a system. We are designing a data layer system, which includes, of course, the database as well, that actually performs, makes sure that your application performs well. The data is stored, the data is retrieved, and you can interact with the system efficiently and basically reasonably fast. So what do we do to design our data management layer? First of all, we select the format of storage. So you have some classes and you want to persist the data in the instances of those classes. You have to decide, okay, do I want to store this data in a file? Do I want to store this data in a database? And if in a database, what kind of database? Then, of course, you need to map the classes to the selected database. So, for example, most common data persistence environment for an object-oriented system which is used is usually the simple relational database management system that you have on your computer. Of course, if you have installed SQL Server, for example. So what we need to do, we need to actually see how we can store the data of object, for example, John, with attributes John, Brown, and data, his date of birth 1/1/2000, and of course the method register. How can I save this in a relational database? Don't forget, a relational database is a format. The format of data is rows and columns, and we have only attributes or columns. We don't have methods or operations in a relational database management system. So this is what we are going to cover today, how we can actually map the classes into a selected database or object persistent environment. Then, of course, afterwards, once we have mapped, then we need to optimize the performance of that storage environment or database. And finally, we need to design the data access and manipulation, or DAM classes. DAM classes facilitate accessing the database. Of course, I'll show you an example of a DAM class in C#. Okay, so let's go to the next page. So what are the different object persistent formats? The simplest that has been around for a long time is just file, simple file. You can store your data as rows and column. As you can see on the slide, we have order number, date, customer ID, so on and so forth. Or we may go for database. So as you know, database is the data is grouped, is organized, and in a relational database management system, the data is in rows and columns, in tables, is organized in tables. And of course, we have on the top of a database, we have a database management system that runs, and which is usually an application or maybe one or more applications that allow you to interact with the data, allows you to run SQL or structured query language commands or statements to insert data, to retrieve data. Now, what are the different types of accessing data in a file? One is sequential access. So you have a file, it's 1000 lines, and if you want to access some data in that file, of course, you go through the each line until you find the data you're looking for. So this, of course, will allow you to read data. It will allow you to add data or search for data. Sequential data can be ordered or unordered. For example, ordered maybe is in ascending order according to one of the columns, for example, the primary key. So it starts with 1, 2, 3, 4, so on and so forth. Unordered, it means it's just there is no ordering according to alphabetic ordering or numeric ordering. It's just some data on the disk. So that is when we access data sequentially, then of course it can be ordered or unordered. Also, we can have access, random access. Random access, basically, we can update data, find data and update data in those in a random access file, and in sequential and random. If we have a mixture, files can be processed, of course, in either sequential or a random manner. What we had usually before having databases, we had several files. One was usually the master file. For example, was storing information about, for example, if it was a sales company, about the orders. Then we had the lookup files, which are usually a list of valid values. For example, I don't know, list of states in the United States. We had then transaction files that were storing the transactions of the customers with the system. And then we had audit files that were recording what a user is doing with the data, for example, customers or internal staff. So that was before we had database management systems. We used to have data separately in different files, and usually that was the organization of the files. Of course, there were many disadvantages with the, having only files. We had to create a program that was reading each file separately and then was managing the interactions. So there was no separation between a database or data and the process, which was not very efficient. Then we had a relational database management system. They came probably around 70s. Now, in a relational database management system, the data is ordered in rows and columns in tables, and tables are linked to each other using a primary key, foreign key. So the primary key of the parent table will go into the child table and becomes a foreign key. So that's how we create relationship between the tables, and hence it's called a relational database management system or relational model. And we have a language was developed called SQL or SQL, structured query language. This language is actually used for two purposes: to create the objects of a database like tables, stored procedures, indexes, and also is used to manipulate data, which you can actually select data, add data, delete data, modify data, or update data. We have many popular relational database management systems like Oracle, SQL Server, MySQL, PostgreSQL. On your computers, you have Access, probably MS Access, which is a single user database. Now, you want to map a object-oriented system into a relational database management system. Then we need to actually look at the classes or class diagrams that we have, or UML class diagrams that we have, and we need to map them into an entity relationship diagram. So you remember, maybe if you have taken a database course, you know that in a relational database management system environment or in a relational model, we have entity relationship diagram. In the UML, we have class diagrams. Now, class diagrams have attributes, and of course, operations we call methods. Interrelationship diagrams, they have entities and attributes. So we don't have methods or operations. So how do we map a object, or how do we store the data about an object in a relational database management system? So that is what we learned today as well. So it's not a direct match, because ERD, or interrelationship diagram, is not object oriented. It's just, it has only attributes. But UML classes, they have they have methods as well as attributes. So we learn how to do the mapping. And another other type of database management systems is called object relational databases. Object relational databases are basically relational database management systems that they have allowed the creation of classes. So basically, some of the database management systems like Oracle and Postgres SQL, they allow you to actually create classes and then reuse those classes. And those kinds of database management systems are called object relational database management systems. Still, we can use SQL to query the objects, and of course SQL is extended in that term for those database management systems. As I mentioned, Oracle is already offering that. So if you go to slides week 1 and install Oracle Database Management System Express that I have given you instructions, this database is actually is a relational database as well as object relational database management system. So it is easier to map our objects and classes into an object relational database than to a pure relational database, because in object relational database we can have classes, and as a result we can instantiate from those classes and create objects. So objects, for example, John, the object John can be saved as a object or as a class or as a type. Person in the database, in an object relational database, the person has attributes: first name, last name, date of birth. And also the person, because it's a class in object relational database, can have methods or operations. So you can actually define the operation register, and what register is doing, you can define the details of the function. So there is a sort of good match between an object-oriented program or system and object relational databases. Of course, you don't see much real implementations of object relational databases. It's mainly for a lack of skills. It's complex. Not everybody has the skill to do that. So mainly, as far as I have seen, even for object-oriented systems, we are still using relational databases or relational models to store the or to persist the object values. Now, a third type of database management systems that we can use, or data models, is called object-oriented databases. This kind of database, they are purely object-oriented, and they are actually connected to the language that we use usually the objects of your program or classes of your program are automatically create the objects, the classes, and of course the instances of that classes in the database. Object-oriented database management systems are not that popular, although they are very useful. Again, it comes down to the skill sets that you need to work with these databases. But actually, these databases directly map the objects or classes in your software into classes in the database, and of course instances of those classes as objects, and so the operations are also mapped into the database. And of course, as I mentioned, they are really mainly linked to the language. For example, if you are creating a Java program, then that object-oriented database management system should make sure that actually supports Java, and of course Java program will create this type of database, usually will create the mapping automatically. We have, of course, commercially available object-oriented database management system. One is Gemstone, Objectivity, DB40, and Verson. As you see, they are not that popular. The names, they are not that familiar to many. But of course, it's good to know about these databases. The other type of databases that we have is called NoSQL or big data databases. These databases usually are useful when you have a huge amount of data, very large amount of data, huge volume. You need fast access, and you have a large variety of data. For example, Facebook is using or Google or other types of social media. They are using this kind of databases because we have a huge amount of data in these databases. Like a video can take up probably maybe a long video can take up to 1 gigabyte of data. And imagine you have thousands of users that they use, they upload videos, for example, or you have a large variety of data. So you have videos, you have images, you have files, you have text, you have so on and so, you have unstructured data. So, and also you need to have very fast access to that data. Like when you watch a video, it's actually accessing the data and streams it through the network at a very fast rate. So for these reasons, if the system you are building has these characteristics, which we call it a large volume, a large variety, and of course a large velocity, needs those three elements, and they are and the data is huge. We usually go for big data databases or NoSQL databases. Why do we call them NoSQL? It's because when you want to work with the database, you don't use SQL. Although SQL can be used behind the scenes, but you don't see that. So you access data using operations, and operations are defined by, depends on which database you are using. So we have, of course, as examples of NoSQL databases, we have Google's Bigtable. This is one type of big data database. We have Amazon DynamoDB, which is a cloud database, big data database. We have Apache's HBase. We have Apache's CouchDB. Sorry. We have Apache's Facebook Cassandra. And we have MongoDB. These are examples. So Apache databases, they are open source. You can go to apache.org, search for HBase or Couch or Cassandra, and download and install and you work with them. MongoDB has two versions, one a community version which is free and one commercial. So you can go to mongodb.com or the MongoDB website, download the database and install it. It's a great big data database. So within the category of NoSQL databases or big data databases, we have key value storage of the data. We have different types basically. So key value stores, they use usually a JSON format, JavaScript object notation. And so the data is stored as key value, like in dictionary. So key, for example, name, value is Ardeshir. For example, key, job, value, professor. So this is called key value, and the data format is usually called or used is JSON. Other type of data NoSQL database is called document databases. It's basically these type of databases are specialized to store and retrieve documents. Now documents are not really structured data like Word documents, like images, like Excel files, so on and so forth. We have columnar databases or NoSQL databases. In a relational database management system, usually we are storing data in rows. For example, one row of data has your first name, last name, and student ID, for example. In columnar databases, we have data stored in columns instead of rows. The advantage of this type of database is that they are very fast in retrieving data if you are doing business intelligence or if you are creating data analytics, if you are using a database for analytics. And of course, we have object databases also in category of NoSQL that I have already talked about. So now that we know different types of data storage environment, how do we select the right data store for our application or for our system? So we have different categories that we have already learned. We have files or sequential and random file access. We have relational database management systems. We have object relational database management systems. We have object-oriented database management system, and we have NoSQL or big data databases. So these are the 5 categories of data storage we have. And we consider different criteria for selecting our data management environment. Now, what are those criteria? For example, if you are looking for so what are the strengths of each of these data management systems? For example, file it has a fast performance and it's good for short-term data storage. So what it means short-term data storage is, for example, a program, you have a object-oriented program that is running, this program needs to just for maybe short term, maybe for a few seconds, needs to store the object's data or locally in a file and then retrieve it and remove that file. So it's good for those kind of persistence, but not for long term. It's usually not very efficient to store data in just a file. A relational database management system, of course, as I mentioned, is right now is the most popular way of storing data. And it can be used, of course, in different scenarios. Object relational database management system. Again, this is it's a good database management system if you have complex data. If you have complex data structure, it can be used. Same for object-oriented database management system. If you have a very complex data and you want your object directly to be persisted in a database management system, object-oriented database management systems are very useful. NoSQL data store also they can handle complex data because the for example, key value per category of NoSQL databases, they can store data in JSON format, and JSON format can handle multidimensional and very complex data structures. So what are the weaknesses of each of these systems? So file system is you create a lot of data redundancies. Relational database management system, if you want to have a very complex data structure, it may not be very efficient. They may not operate very efficiently. Object relational, if there is a mismatch between your program and the database, it can create that there's not enough support for them. Object-oriented database management system, the technology hasn't really matured yet. Sorry. We don't have much skill set or experience in that area. And of course, NoSQL, again, this is a new area. The technology is still maturing. Now, so what are the data types that are supported? Basically, all of them, they can support both simple and complex. But relational database management system usually is best for data that is not that complex. Files, they can support, of course, transactions, type of applications, and the same for a relational object and for object-oriented, and of course NoSQL. And if you look at the future, probably files are not going to be used much. Even right now, they are not used much for data storage. Relational database management systems are very popular right now. So in the future, they should be continuing to be popular. Object relational systems also, they should have a good future, the same as object-oriented, and of course NoSQL databases or big data databases. So if you want to learn about relational database management system, object relational database management systems, object-oriented database management system, and NoSQL both they have good future. So how do we in this course we try to map an object-oriented program or object-oriented system into a relational database management system like SQL Server, for example. So what do we do? What are the steps? It's actually a simple process, really. It's not that difficult. So first thing we do, we map all our concrete classes. Do you remember in the class diagram? We have abstract classes, we have concrete classes. Concrete classes are classes that we can instantiate objects from them. Abstract classes are mainly used for inheritance. So all the concrete classes, for each concrete class, you need to create a table. Then you look at your attributes in your class. For each class, or for each concrete class, all the single valued attributes are mapped into a column in that table. How about the methods? The methods in your classes are converted or mapped into a stored procedure. Stored procedures are small are procedures that we can store in the database. They run in the database, and they can do things for you. So in object-oriented programming, of course, you define what a method can do. Similarly, you can define what that the same method can do in a database, in a relational database, but using stored procedures. Stored procedures are basically programming inside the database, and so you can define using a combination of SQL and control flow. We call it transact SQL in SQL Server, and we call it procedural language in Oracle to create really programs. And then, of course, how about relationships? So you map single-valued association relationship to a foreign key and multi-valued attributes to one-to-many relationships, and basically that's what we do. And for the rest, of course, we need to, for example, if we have inheritance in your class diagram, you need to flatten the inheritance by you copy the superclass attributes, for example, to the subclass, and then you have those attributes. So do you remember in a class diagram, if we inherit from a superclass, we don't write the attributes of superclass in the subclass because automatically they are considered when you run the program. But when you map it to the relational database management system, you need to repeat those attributes and operations in your when you are mapping it to a table in a relational database management system. So in summary, when you want to map create a table for each concrete class, and create in those tables create a column for each attribute, single valued attribute of those classes. You create a single column, and when you do that, of course, you need to bring all the attributes and operations of superclasses into the subclasses, and so that's how we do it. Now, so that was the mapping part. Now, how do we actually create the data access and manipulation classes? What are they? These are basically they act like intermediary classes or translators between the database management system and your objects in your software. So they should allow you at least to add data to your database, read the data back from the database, and of course populate. That should allow you to populate your objects when you are working with the objects. So we should have one data access and manipulation class, or DAM class, per each concrete class. So let's have a look at an example. Here we have a vendor class, and we have a product class. So one vendor may have 0 to many products. That's the relationship. The attributes of vendor is vendor name, contact first name, contact last name, phone number, and vendor ID. What this vendor can do: vendor can add product, and of course vendor is constructor class, a constructor function or method. Then we have product. Product attributes are product name, product description, date, is it active or not, the price of the product, is it approved, and of course the product ID. Product ID actually creates the is used for creating relationship. Now, so for a vendor, which is a concrete class, we create a vendor DAM or data access manipulation class. This class should allow you to read data from vendor, add data to vendor, read product and write product, of course, which is product is part of vendor, because one vendor can have 0 to many products. And we have, of course, product data access manipulation class that can read and write data. Now, so what we do, as I mentioned, pair, if you want to map it into a relational database management system, per concrete class, we create a table. So I created a table for vendor. The attributes, they come here: vendor ID, contact first name, contact last name, phone number. I create another table for concrete class, product. The columns are product ID, product description, date, active price, approved, and vendor ID. So as you can see, I have mapped attributes of concrete classes into a table in a relational database management system. Of course, this is a representation of the tables when they are built. So I need to build this, of course, in my database. So I created vendor table and product table, and I created the relationship between them. Now, let's go and see an example of a DAM class. So we have a company called Short Products. Short Products is a company that sells products, we have vendors, we have products. Two main basically objects of that that supports the operations of that company. So what we do for creating the data layer, to design the data layer, what I do, I create a database called Short Products. Don't forget, in this case, I am mapping my classes into a relational database management system. I created a table called product. These are the columns. I created another table called vendor. And of course, I created a relationship between them. So that's my entities in the database. Then I created the classes, the DAM class and the DAM classes for vendor and DAM class for product. So this environment that you see is Visual Studio environment. And of course, I have given you the instructions how to install it. Let me show you the code for the vendor DAM class. So vendor DAM or DAM class is defined here, vendor class. And what I do in this class, I connect to my data source, which is my SQL server, as I showed you on my laptop. And I am actually logging as system admin, and this is the password. Of course, I give you the code for this, and you can try it on your computers as well. And then, of course, I open the connection, and Then what I can do, I can then read data from vendor. For that, I select a vendor ID, vendor name, so on and so forth, from my table. So that's SQL, where vendor name is whatever I choose. And this is the rest of the code. Basically, for each read or write, I should write a separate definition of the operation. And as you can see, of course, as I mentioned, you will have access to all this code. It's in C#. Then, how about product DM? So let's have a look at the product DM. Product DM is basically has no operations, nothing, because product is a part of a vendor, and therefore we don't need to really directly access the product. So we just have a look at the vendor class, vendor DAM.cs, which is really shows it's a class in C#. CS stands for C#. So let's run this. This is actually a simple web application. So let's run this simple web application and see how it works. To run it, I have of course already created a user interface that you saw already. So I go to content. No, it's not content, it's pages. Pages and vendor. So this is basically the, So this is a graphic user interface that I created for this application. So let me run this application. It's a web application. So as you can see here, it allows me to vendor name, it allows me to enter data. So I say vendor name, for example, what? Let's choose a vendor, maybe Microsoft. The contact first name is Bill, last name Gates. His phone number 1231234. Okay, whatever. Now, when I click submit, the submit button actually goes and takes this data and gives it to a DAM class called vendor DAM class. This data is then inserted into the database. So let's do that. Click OK. Now if I go to my database, I should have my data there. Let's see. Yeah, I have it at the row 5. So Microsoft, Bill Gates, and this is his number. So what we do, so what you see here is a real object-oriented program which connects to a database. So we have product class, that's the product class. We have vendor class. For each class we have data access manipulation class. This is for product. For vendor also we have data access manipulation class. And of course we have the user interface to use those classes under the pages. For example, under the vendor we have this user interface. This is in HTML. If you go to design, you will see that. So what I do, I will give you the full code for this application and instructions as how to work with that application is here. Go through the instruction and see if you can actually create a database and use the code. It's a very good exercise for you to understand how a real object-oriented programming works with database and how we map classes or objects into a relational database management system. So these are the rest of the instructions. I will upload these files, vendor.cs, product.cs, and also the SQL for creating database. I'll upload it in week 8 module. Now a little activity for you. Create an entity relationship diagram for the following class diagram. So You know how to do it, huh? So we have employee class, we have project class, we have billing. If you want to create an entity relationship diagram, in other words, if you want to map this class into a relational database management system, what are your entities and what are the relationships? So please do this activity. On week 9, we will have a look at what you have done. I think that's all for today. So I'll see you in week 9. Take care and have a nice week and weekend.